Hey everyone, welcome back to my channel and welcome back to the JetBase series. In the previous CRUD series, we learned how to store, display, update, and delete data in Firebase real-time database. Now, in this CRUD series, we will learn how to store the image, display the image, update the image, and delete the image using Firebase storage or cloud storage. See, these are all the services provided by Firebase. We are not covering all of them, but the important one, out of which we have used app check for OTP, authentication for login and sign up, Firebase ML for ML projects, real-time database for storing the data, and now cloud storage, also known as Firebase storage to store the media files. Also, cloud storage and cloud functions are two different things, so don't get confused between them. Cloud functions is a framework that runs backend code. Now see, we can store media files in real-time database also, but it is not recommended because of the size of the media files, which are big files in MBs and GBs. Hence, we are supposed to use cloud storage. Cloud storage can store images, audio files, and videos. So, usually, when we create a project that requires storing text as well as images, we use Firebase real time database and Firebase storage both. We will do that when we create a big project. But for now, not to confuse you, we will use CRUD for images only. No text, okay? Now, let me show you the demo. It's a basic Pinterest app where you can add an image by clicking on the Fab. It will open the gallery, choose an image, and see. Here there are 6 images already stored. Refresh it, and look, our new image is successfully stored in the cloud storage. Here in the app, refresh the screen, and look, our image is displayed. Great! All the images are displayed in a staggered layout, like how the Pinterest app is, right? Also, I'll tell you something that media files take a little longer time to load because of their size. And also, Firebase storage is not real time. Hence, we need to refresh it whenever required. Now, you can update the image by replacing it with another image. So, click on the image and it will again open the gallery. Choose an image and the current image will be replaced by the new image and it will be updated in the database. Lastly, by clicking on the delete icon, you can delete the image from the database. And see, it's gone. Easy, right? Again, we will divide the project into 4 parts: create, read, update, and delete. This is our create video where we will only store the image in the database. Okay, so let's write the code for it. Open Android Studio, choose Empty Views activity, name the project My Pinterest app, and click on Finish. Let's set up the Firebase. Open Tools, Firebase, choose Cloud Storage, and click on Get Started with Cloud Storage. Then click on Connect to Firebase. It will open the Firebase console automatically. I'll keep the name as it is. Follow the steps as shown on the screen. And done. Then in the project, choose Cloud Storage. The cloud storage requires a premium account of Firebase, which is Blaze. Currently, I am using Firebase Spark, which is a free account. Now you do not have to spend any money, you just need to upgrade your account as shown. To use the Blaze account, we also need a cloud billing account. I already have one, so I will just use that one. Also, while creating a billing account, it will ask for an autopay of 15,000. But don't worry, it won't cut your money at all, it's just formalities. Once you have a billing account, link it with your Firebase. And there you go. See, it says pay as you go. So it will charge you money only if you use their premium service or anything above the limit. After the project is done, cancel the autopay. Simple. Now click on Get Started. Choose the server location. Start in test mode. And done. Our cloud storage is set up. This is where the images will be stored. Now come back to Android Studio. Click on Add Dependencies, Accept Changes, and done. Then go to Gradle, add these 7 dependencies. I'll mention them in the description box so you can copy and paste them. All of these are for Firebase, Lifecycle, Navigation, and Coil. The coil is used to display images. Click on Sync Now. Now create a data class, Image Data. Here we want to store 2 data parameters. The one is image name and 2 is the image URL. Both of them are string. We are storing image name so that we can later update or delete the image based on its name. Like how we have a unique ID for the data, here we have image name which is also unique. Then we obviously need screens. Hence create 2 screens. The first is add image screen where the user will be able to add an image. The second is display image screen where the images will be displayed. That's it, just 2 screens only. Then we need navigation between the screens, right? Hence to set up that, go to main activity, remove the default code. This is where we handle all the navigation. Hence for that, create a composable function, My Pinterest app. Add name controller, then name host, which has 2 parameters, nav controller and start destination. Our start destination is display image screen, whose root is display image. Hence write here the root and also create a composable for it. Then create another composable for add image screen, whose root is add image, and done. These errors will be gone after completing the code. Do not forget to call My Pinterest app function here inside the set content. Then next, remember how we used to have a repository for CRUD to store its instructions? Likewise, we will create a view model where we'll store the real logic for CRUD. You know what a view model is, right? View is the UI, model is the data, and view model is the logic. That's how I remember. Consider this image data class as the model, these 2 screens as the view, and now the view model. This view model will consist of CRUD logic like uploading the image, fetching the image, updating the image, and deleting the image. Hence, create a first variable Firebase storage, which initializes Firebase storage. Then create image data list, which consists of mutable state flow, list of the image data class. Initially, it is empty. This image data class will consist of all the images stored in the database. Simple. Now, as we are only storing the image today, hence we will write the logic only for upload image. Create an upload image function whose parameter is URI. URI stands for Uniform Resource Identifier. URI is not URL. URL stands for Uniform Resource Locator, which specifies only the location of the data. But a URI can be a name, location, or both. We are storing image name and image URL both, hence we are using URI. Got it? Basically, we are uploading an image to Firebase storage and saving its download URL. It starts by creating a unique file name using uuid.randomuuid.toString. This ensures that each image has a different name. Then we create a reference to where the image will be stored in the Firebase using Firebase storage.child file name. Remember how we used to have a child node as ID? Here we have a child as a file name. The actual upload process happens inside a coroutine using viewModelScope.launch, which helps us run the code in the background so it doesn't face the app. And that's what a coroutine is, right? They prevent the main thread from getting blocked. Inside the try block, we upload the image file to Firebase using putFile URI.await and wait for it to finish. That's what we use await for. After that, we get the download URL of the uploaded image with download URL.await.toString. Then we create an image data object using the file name and the URL and add it to the top of our image list using image data list dot value is equal to list of uploaded image plus image data list dot value. So the newest image appears first. If anything goes wrong during this process, the catch block will catch the error and print it. Our upload image logic is done. Then next, go to add image screen. This screen will open the gallery. So when the user clicks on the add fab, the screen will launch the photo gallery and then the user can select a photo from it. Simple. But first, we need an add fab that is present on the display image screen. Hence, first let's write the code for it. This is our display image screen whose parameter is nav controller for navigation. Also make it composable function. Then create a scaffold which consists of a floating action button whose on click will navigate the user to add image screen using its root add image. The fab container color is red and its icon is the add icon whose content description is add. Now, as it's a scaffold, so it will throw a padding error. Hence, to fix it temporarily, we will add a box using padding. And that's it. For now, this is enough. We will write the complete code for display image screen in the part 2 video. Then come back to add image screen. Make it a composable function. Here, we are letting the user pick an image from their phone gallery and then uploading it to the Firebase. So focus. Opening the photo gallery logic is not limited to this project only. If you are creating some other project and there is a need to open a gallery, then you can use this code, of course. Add a nav controller for navigation. Then we will be using the upload image logic from the view model, hence calling its class here using view model. Now to launch a photo gallery, first we need a launcher and second we need something to launch it. First we set up a gallery launcher using remember launcher for activity result. This is a special helper in Jetpack Compose that launches a system activity like opening the gallery and gives us the result when the user is done. We use activity result contracts dot start activity for result because we want to start an activity and get a result back. Inside the result block, we get the selected image using result.data .data. This gives us the image URI, which is basically its location on the device. We check if URI is not null and if it's valid, we pass it to our upload image function in the view model to start uploading it to Firebase. Next, throw a toast using the context variable as image stored successfully. After that, we call navcontroller.popbackStack, which takes the user back to the previous screen automatically once the image is picked and the upload starts. Next, we use launched effect unit to make the gallery open as soon as the add image screen appears. Inside it, we create an intent using intent.actionPick mediastore.images.media.external content URI, which tells Android we want to pick an image from the gallery. Then we launch this intent using gallery launcher.launch gallery intent. So in short, as soon as the screen is opened, the gallery pops up, the user picks an image, we upload it and then navigate back all in one flow. And with that said, our storing the image code is done. Now let's run the app and check. There was a duplicate class error, hence remove Firebase storage and keep only Firebase storage KTX. Now let's run the app again and see. This is our first screen, display image screen, which is obviously empty because we have not yet written the code for it, but we did write the code for fab. Hence, click on it. Look, we are navigated to the photo gallery. I'll choose an image and we are navigated back to the display image screen where the toast says image stored successfully. Refresh the database and see we have the image name as well as its URL in the database. Now in the next video, we will display that image here in the display image screen using staggered layout. Okay? So yeah, that's it for the video. If you are new to this channel, then please consider subscribing to my channel and I'll see you in the next video. Hey everyone, welcome back to my channel and welcome back to the JetBase series, a mix of Jetpack Compose and Firebase. In the previous video, we learned how to store an image in Firebase Cloud Storage. And now, in this video, we will learn how to retrieve the image from Firebase Cloud Storage and display it using a staggered layout. So open the My Pinterest app project. We have already set up the navigation for display image screen in main activity. Hence, let's directly go for image view model. As I said, image view model consists of CRUD logic, where we already have the logic to upload the image to the Firebase database. And now we will write the logic to fetch the image from the Firebase database. Simple. To do that, create a variable image list whose data type is a state flow. List of image data class is equal to image data list. Now, why do we have two lists? We actually have one list only, but with two different reasons. This image data list is a private list that only the view model itself can change or update the list. While image list is exposed to the UI, it is only a readable list. Mutable state flow, the word mutable means it can change. And state flow, which is not mutable, means fixed. But why is that so? Because it prevents bugs by making sure that the UI doesn't accidentally modify the data. It's only supposed to display the data. Then let's write the code for the fetch image function. This function fetch images, it is used to get all the images that we have stored in the Firebase storage and display them in our app. It runs inside viewModelScope.launch, which means the code is launched in a coroutine, so it doesn't block the main thread. Then inside the try block, first we call Firebase storage.listAll.await to get a list of all the image files stored in our Firebase folder. Then we go through each image using .mapNotNull. And for each one, we try to get it download URL using image.downloadurl.await.toString. We wrap this in a try catch to safely skip any images that fail to load. For each successful image, we create an image data object with the image name and its URL. Finally, we update our image list using image data list dot value is equal to all URLs dot sorted by descending and sort the list in descending order by image name. So the latest uploaded image show up first. Then the catch block will print the exception error. This function is very important because it refreshes the image gallery and keeps our list updated. Next, go to display image screen. This is where we will display all the images using a staggered layout. We have a floating action button from the previous video. And now let's write the complete code. First, declare and initialize the image view model because that is from we will get the fetch images method, right? Then we will connect our view model's image list to the UI using image list. This line collects the list of images from the view model using collect as state, which converts the state flow into a state that the UI can observe. Then add the imports. Next, we have a launched effect unit which runs as soon as the screen opens. Inside it, we call imageViewModel.fetchImages to load all the images stored in the Firebase and display them on screen. Then next we have the scaffold, which helps us build a standard screen layout with a top bar and a floating action button. Floating action button is already done. So for the top bar, we show the app title, which is My Pinterest App, with container color as red and title content color as white. Opt-in for experimental API. Then in actions, we have a refresh button. When the refresh button is clicked, it fetches the latest images by calling fetch images and updates the UI. I'll set a refresh icon with content description as refresh. At the bottom right, there's a floating action button with a plus icon. When the user taps it, we navigate to another screen named Add Image, where they can add a new image. Inside the scaffold body, we have a box with fill max size. Then we use lazy vertical stagger grid, which displays the image in a Pinterest style layout. I have kept the column stagger grid cell size as 150 dp and lazy vertical stagger grid as fill max size, covering the entire screen. Next, we loop through all the items in the image list and show each image item. Make sure the items import is a list. Lastly, use async image to display an image from the internet in our UI. It's part of the coil library, which helps us load images efficiently without slowing down the app. We pass the image URL using model is equal to imageitem.image URL, which tells it where to fetch the image. In our case, it's coming from Firebase storage. The content description is set to null. Finally, we use modifier.fillMaxWidth to make sure the image stretches across the full width of its container, so it fits nicely in the grid layout. And that's it. Now let's run the app and check. Look, the previously stored image is displayed on the screen. Great. Let's add a new image. Click on Fab, select an image, refresh the database, and look, the image is successfully stored. Now refresh the screen using the refresh button, and look, our new image is also displayed successfully. Amazing! We will cover padding as well as update image and delete image in the upcoming videos. Okay? So yeah, that's it for the video. If you are new to this channel, then please consider subscribing to my channel, and I'll see you in the next video. Hey everyone! Welcome back to my channel and welcome back to the JetBase series, a mix of Jetpack Compose and Firebase. In the previous video, we learned how to display an image from Firebase Cloud Storage. And now, in this video, we will learn how to update the image in Firebase Cloud Storage. So open the My Pinterest app project. In the update case, we simply replace the current image with a new one. When the user clicks on the current image, the gallery opens up. From there, he can choose a new image and replace it with the current image. And that's what an update image is. Hence, directly go to Display Image screen. This is where we will update the image. So we start by declaring a mutable state variable, current image, using remember and mutable state of. This variable holds the currently selected image of type image data, that is nullable. The reason we need current image is to track which image is being modified or replaced by the user. Next, we define a gallery launcher using remember launcher for activity result, which allows us to launch an external activity, in this case, the photo gallery. Then using the activity result contracts dot start activity for result, it is used to get results from an activity, such as selecting an image. From this result, we attempt to retrieve the URI of the selected image using result.data?data. If the URI is not null and current image is also not null, which indicates that the user has selected an image and there is already an image present that they intend to replace. Inside the if block, we first delete the currently displayed image using imageViewModel.deleteImage. Current image, double exclamation marks. The double exclamation marks are used to declare that the current image is not null. Now, as we'll be writing the code to delete the image in the next video, hence I'll temporarily add the delete image function in image view model. I'll explain this function in detail in the next video. But for now, understand that this function deletes the image from the database. Okay? So after deleting the old image, we proceed to upload the newly selected image to Firebase by calling imageViewModel.uploadImage URL. Finally, we reset current image to null, which cleans up the previous state. Then, once the logic is ready, let's apply it to the clickable. Also, remember in the last video we had a padding issue. Let's fix that also by creating a box inside the items image list. A box with padding 4 dp and a clickable. This box clickable makes the image clickable. Hence, put async image inside the box body. When the user taps on the image, the first thing that happens inside it is that the current image is set to the image item. This step records which image the user wants to replace. It's important because this image will later be deleted before a new one is uploaded. After that, we create an intent using intent.actionpick.mediastore.images.media.external content URL. This intent opens a phone image gallery, allowing the user to pick a new image. Finally, we call gallery launcher.launch gallery intent to launch the image picker activity and wait for the result. That result is handled in the gallery launcher block as I described earlier, where the selected image will be uploaded and the current one deleted. And that's it. Our update CRUD functionality is done. Now let's run the app and check. We have two images present in the UI as well as in the database. So I want to update this image with a new one, hence I'll click on it. Look, the gallery opens up. I'll choose a different image and see our old image is replaced by the new image in the UI. You can refresh the database to see the updated image. And there you go. In the next video, we will learn how to delete the image from the database. Okay? So yeah, that's it for the video. If you are new to this channel, then please consider subscribing to my channel and I'll see you in the next video. Hey everyone, welcome back to my channel and welcome back to the JetBase series, a mix of Jetpack Compose and Firebase. In the previous video, we learned how to update an image in Firebase Cloud Storage. And now, in this video, we will learn how to delete the image from Firebase Cloud Storage. So open the My Pinterest app project. We will write a simple logic to delete the image from the database in image view model. We already have fetch image and upload image logic, hence create a new function, delete image. The delete image function is responsible for removing an image from Firebase storage and updating the local UI state accordingly. It takes an image data object as a parameter, which contains information about the image to be deleted, such as the image name and its URL. Inside the function, we launch a coroutine using viewModelScope.launch to perform the delete asynchronously. This ensures the operation runs in the background without blocking the main UI thread. Within the coroutine, we use a try-catch block to safely handle any exception that may occur during the deletion process. Inside the try block, we call Firebase storage.child image.imageName delete.await to locate the image in the Firebase storage using its unique image name and delete it. The .await function is used to suspend the coroutine until the deletion completes, making it a smooth experience. After successfully deleting the image from Firebase, we update the local image data list state by filtering out the deleted image. Ensures that the UI reflects the updated list of images without the one that was just removed. Finally, if anything goes wrong during the process, the catch block catches the exception and prints the stack trace for debugging purposes. And then go to display image screen. This is where we'll create a small delete icon button on the image. Look, this is our box which is clickable and it consists of an image and an icon button. The onClick parameter is the main action that will trigger when the user taps the delete button. In this case, we will call imageViewModel.deleteImage image item, which initiates the deletion of the specific image item by calling the delete image function which we created. This removes the image from Firebase storage and updates the UI. The modifier is equal to modifier.alignment.topEnd. Aligns the delete icon button to the top right corner of the box or image. Inside the icon button, we add the delete icon using icons.default.delete and provide a content description as delete. Some people cannot recognize the icon, hence we add content description so when the user hovers on the icon, it displays the content description that is delete. Got it? And that's it. Our delete CRUD functionality is also done, and so is our app. Now let's run the app and check. We have two images in the UI as well as in the database. I want to delete this image, hence I'll click on the delete icon button, and there you go. The image is successfully deleted from the UI. Refresh the database, and it's removed from the database as well. Great. Let's revise everything. First, to add the image, we use a launcher and an indent to open the photo gallery. Select an image, refresh the database, and look, the image is successfully stored in the Firebase cloud storage. Refresh the UI using the refresh button, and a new image is displayed successfully using the fetch image function. Then to update the image, I'll click on the image and replace it with another image. The new image is updated in the UI. So refresh the database to see the updated list of the images. Now I want to delete this image. Hence click on the delete icon button and the image is removed from the UI using the delete image function. Refresh the database. Great. I'll quickly add more images and look so cool. Let me know in the comments if you guys need a tutorial for Firestore. Okay? So yeah, that's it for the video. If you are new to this channel, then please consider subscribing to my channel and I'll see you in the next video.